All right, we got the recording going. I just wanted to show the announcement tonight. We are going to be working on thread repair, or talking about it, I guess. Um, and I also did update your grades today. So that means that you guys who are with me here this spring in AT 100, every assignment that you guys have done, I believe I have graded it now. You're up to speed. I've even added in the extra credit points for you guys being with me on Zoom, which is fantastic. And by and large, I feel like the grades are looking really good. So you guys are lighting yourselves up really nicely. Um, I guess to follow up on this, right? The big question is, hey, where do I go from here? Like, if I want to know more about cars, if I actually want to be doing some, um, you know, hands-on work on cars, what's going on? Okay, well, we have a number of classes this summer, which are they're probably getting pretty close to being full, honestly. In fact, let's go to the summer schedule real quick, um, and we'll go in here and we'll say automotive. Now you'll notice that there's automotive mechanics technology, AMT, and then there's AT. AMT is our sister college at Consumnes River. So, and our classes do transfer back and forth to a certain extent. So, that's an option for you. If there's a class that you need that you can't get into, you might want to check out the guys at Consumnes. I actually used to teach at Consumnes years ago, and they're good guys out there. Good folks. But ARC, our designator is AT, so we'll put that in. And so you can see we have a few seats left in the 140 class, a few seats left in small engines. And then these other classes are pretty advanced with the engine performance and smog. But let me talk about these real quick. Um, I think a great place for you guys to go from AT 100 would be to jump into AT 140. Now, that is not the normal way that we do it. However, um, I'm modifying stuff so that you guys can get lots of hands-on time, and to kind of make up for maybe what you weren't able to do in here, hands-on speaking, to do it in skill and speed. So we will have some online lectures and information, but you'll show up in class to work on projects. And what we'll do in that class is kind of come up with a customized learning plan for each student in there. So if you're just beginning and you're like, look, I want to focus on getting better at doing basic services, then that will be your customized plan, right? If somebody comes in and they're more advanced and they've had the suspension and brakes class or engines class, maybe they do something related to that. But the idea is that we can help you build up your skill and speed doing repairs, working on cars, and we kind of customize it to your personal goals. So the first day of class, so to speak, or even before the class starts, we start helping you kind of decide what those goals are going to be. So the small gas engine class is going to be online, but because school's back in session, we can set up individual meetings if you need help working on projects. And I have engines and stuff for you to check out and work on. And then these classes really are what I call the capstone classes of our program here at ARC, with engine performance and smog checks, so that you can get your smog tester's license. So those are really, we put them in the schedule to try to help out our students that were almost at the end of the program when everything closed down due to COVID-19. So in the fall, we will have all kinds of stuff. We'll have a lot of stuff online. AT 100 will still be online. However, we'll have classes like brakes and manual transmissions, again, skill and speed development, parts. We'll have classes such as these that are in person. So hopefully you guys can check those out. All right, let's move back to AT 100. We're doing thread repair tonight, and there is a couple assignments related to that this week. unfortunately, the way things stacked up, in fact, let me look at the student view. I apologize, guys. Stuff kind of stacked up, and then we ended up with a bunch of stuff due here right at the end. Just the way that the semester kind of ends in a midweek. So I will move these extra credit things down to the 19th, which is the last day of our spring semester. We have a bunch of things due here. A lot of you guys that have been with me for all these Zoom sessions, if you look at your grade, you might have a bunch of extra credit points. You might choose to skip one of these, or it's up to you, right? Points are points. But basically, I overlapped the fasteners with the thread repair. Normally, when we're in regular school, we do those all in 1 week anyways. Normally, we do those two activities together. But the way it looks on Zoom, it looks like a lot of stuff. Or I'm sorry, the way it looks like on Canvas, on the Canvas calendar, okay? So the next week, we'll be talking about electrical systems. And then our last week, we're going to be talking about scan tools and just some basic engine diagnostics, okay? So like things to try if your car doesn't start, that type of thing. And that's how we're going to wrap this thing up this semester. So we will have a Zoom session. Obviously, we have ours going on tonight, May 4th. We'll have one on the 11th, and our last one will be on the 18th. And that's how this thing's going to close out. So, it's coming up super fast. So with that, let me change my screen share, and we are going to go to tonight's presentation, and we're going to hit the highlights. This is also embedded in Canvas. I think Larry Haw does this one. I can't remember who I have doing this particular one. All right, so with that, let's put it on our other mode so I can get it centered out a little bit better. There we go. And we'll hit the highlights, and then if we get through it and we have some time, we can start getting into some diagnostics. Okay. So with that, let's get going. So last week we talked about reading the thread pitch of a bolt, and so for example, guys, here, we have a. Hang on, let me get my annotation tools up here. So see how this says 16? So this is a standard bolt, and the thread pitch, or TPI, is 16, oops, not 61, 16 threads per inch. So in 1 inch of that bolt's length, you would count 16 threads, okay? And we got our pitch gauge in there, and we're measuring it out. And I don't know the size of it. You'd have to put calipers on there to figure out the size. Maybe it's a 3/8 bolt. 3/8 by 16 is pretty common. That's what it looks like to me. And then, of course, on the top of the screen, I have a metric that's an M12 by 175, which is kind of a coarser thread. You'll see a lot of M8s by 125, M10 or M12 by 1.5. So we got metric at the top, standard at the bottom. Okay, so part of our job when we're doing this type of work is to identify what threads are we fighting. Okay. So this is going to go over a little bit of our normal project inside the auto shop. And it's a good project. It's pretty easy project though. We use a piece of aluminum for this project, and the reason we do it is because aluminum is a soft metal, and so it's easy for drilling and tapping and all that type of stuff. One tip I have for you, and I thought I had my magnet up here, and I don't. But if you're ever working with a piece of metal and you're wondering, hey, is that metal aluminum, or is it or is that metal cast iron or steel? You know, I'm going to just draw one. Put a magnet up here, right? Trying to draw a horseshoe magnet, and I'm doing not a real good job, but with my north and south poles, put a magnet on that piece of metal and see if it sticks. Even if it's the engine block in your car and you think, hey, I wonder if my engine block is made out of cast iron or is this an aluminum engine block? Again, magnets don't stick to aluminum, but they'll stick to cast iron and to steel. And so in the machine shop, we almost always keep a magnet in our pocket so we know what we're working with, okay? And having a pocket magnet is a really handy tool to have in your pocket at all times when you're working as an automotive tech. All right, we will clear out those drawings and keep stuff moving forward. So if you're ever going to drill a piece of metal, I don't care if it's aluminum, cast, if you're going to drill something and you don't want that drill bit like wandering around on you, center punch it. And what that center punch does is it puts a little divot in the metal, and that will allow your drill bit to have something to center off of so it's not moving all around. Okay. So always center punch your components before you go to drill them so you can drill with some precision. Okay. So we do that in our activity. And then we look at a tap chart. Okay. Now this one happens to be inside the tap and die set that we were using. I have one right here. We buy a lot of engine parts from Goodson and we hang these over the walls of our shop. And it tells us some information about what the thread size is in relation to, well, how big of a hole do I need to drill? Okay. And it gives us decimal equivalents. So remember how last week we talked about how, like 2 weeks ago, we went into precision measurement and we said, hey, having a dial caliper like this is super handy to have. Well, you can go from your decimal measurement, right, to your drill bit size. I mean, these things are all related. So let's take, we were looking in that one image of a 3/8 by 16 is what I thought it was. So 3/8 by 16 is a national course thread. We would drill the hole with a 5/16 drill bit that if you measured that drill bit, it would measure out 312 thousandths and 5/10. Okay. Basically 312 thousandths and a half. So it's hard to tell when you're looking at drill bits, there is numbers on them, but a lot of times the numbers get worn off or it's just hard to read if you're an old guy like me. So I'll put them in a caliper like this and I'll read them. Okay, so this one is 220 thousandths. So it's probably, somewhere between a number 3 drill bit and a 17/64. In fact, one thing about drill bits that you may not realize that I'll point out on this chart here is that you notice that you can have drill sizes that are numbers. So that says number 43. You can have drill bit sizes that are fractions, 17/64, or there's one that's 5/16. You can also have drill bits that are also letters. And I don't have any of those listed on this chart, but drill bits come in numbers. They come in letters. And they come in fractions. I'll just put 1/8 here for a fraction. So those are different sizes that you can get drill bits. What you typically at the hardware store get is your fractional drill bits. But when you're doing stuff like this, you might need to buy a special numbered drill bit, which are usually the smaller sizes, or you might need to buy a lettered drill bit, which kind of get in some of these in-between sizes. Okay, so you use the chart to figure out what size drill bit you need. And then if I clear out these scribbles, then you can drill that hole to the appropriate size. Now, I will say if you're drilling something by hand, right, like where you hold the drill in your hands, you got to be really careful to be perfectly straight on. Or another way I'll put this is that you really want to be, let's pick a different color, something that maybe stands out more. You really want to be 90 degrees, right? Perpendicular to your work surface. If you're coming in at an angle, you're not going to be able to tap very good threads in that metal, okay? And you certainly don't want to be wobbling all around. So if you're going to do a lot of precision drilling, having a drill press is really nice to have, to be honest with you. It really makes things easier and it allows you to do a higher quality job. Okay, so here we're drilling the hole. You got to think, hey, is it going to be a through hole or a blind hole? On this thin piece of metal, it's a through hole. And then you're going to choose a tap the same size as your bolt. So taps are to cut threads into holes. Here's a tap right here, is to cut threads into holes. You know, one way to think about taps and all these thread cuttings, it's not too much different than drill bits. Like drill bits, even if you buy some stuff from Craftsman or Snap-on and they say they have a lifetime warranty, the drill bits don't have lifetime warranties. Neither do the taps, neither do the dies, because these are considered consumable items. That means that, you know, that they'll wear and they'll break. And so we really have to take care of them. One of the things that I do when I'm drilling holes, or if I'm using a tap, is I will put some oil on these threads to lubricate the threads. And I'll go a little bit and I'll take it out and I'll clean it off. And that way I'm not putting too much strain on these, on the tap, especially if I'm tapping into a really hard material. Okay, if I'm tapping into cast iron or a high quality steel, I really got to be careful with what I do. Now, you notice that there's different types of taps. There's taper taps, plug taps, bottoming taps. This center tap's kind of like your normal one that you get in a set. Of course, if you have a blind hole, and I'll go back a slide here. If you have a blind hole like this one right here, if you want to have threads all the way at the bottom of that, then what you need to have is that bottoming tap, right? So there's different taps to do the job. And then of course, they obviously come in different sizes and thread pitches, okay? So it's not uncommon for, as a mechanic, to have like a nice big master tap and die set, both for metric and for standard threads. And then on top of that, you might get yourself in some weird situations where you got to buy individual taps or individual dies to do some specialty work. I will say that I spend more time using my taps than I spend using my dies. But anyways, now back to that lifetime warranty thing. Usually it's only the tap handles that have the lifetime warranty, not the taps themselves. Okay. Think of it, you know, they're like drill bits. They're kind of a consumable item, like tires on your car, right? So, the important thing about using a tap is you drill the hole the right size. As you're tapping these threads, you're cutting off chips and they're going into those flutes. So what you have to do is back off the tap a quarter turn to break off any metal chips. Use cutting oil. I'd say it's always necessary. So you go around and then you go back and break off the chip. And then you go around and you go back and you break off the chip. Now, if it's a real hard material, I might only go a half a turn and go back and break off the chip, or 3/4 of a turn and go back and break off the chip. I might not do a full revolution before I break off that chip. It depends on how soft and easily machined the material is. The harder it is, the slower I need to go, and the more often I should be breaking off that chip. Okay, when you're all done, you know, you'd end up with threads that look something like that. And they should be nice and square. And if you put a bolt in there that's the right thread pitch and size, it should feel nice and snug. If it feels all loose, what that means, either when you were drilling the hole or when you were using your tap handle, is you were likely getting some side-to-side movement. And so then it was elongating that hole. And it's, you know, doing the stuff's tricky to do. So if you've done it right, it'll thread easily in that hole. It won't bind. It won't be loose. It'll fit snug. Okay. Now, in this picture, I do want to point something out. If I get rid of my drawings here, I see that there are 1, 2, 3 lines on here. So that is not a grade 3. That's a grade 5 bolt, right? But that bolt is threading into an aluminum plate that's maybe 1/4 of an inch thick. So the bolt, what I'm getting to is the bolt is way stronger than the threads in this aluminum. Aluminum is a soft metal, right? It's like your soda can. So whenever you're torquing parts down, and we were talking about using torque wrenches and stuff last week, keep in mind, it's not just the fastener, it's the materials. Like, what am I tightening into? If I'm tightening into stuff that's made out of aluminum, those torque specs are going to probably be set not by the fasteners, but by the aluminum components themselves. And so if I were to tightening this up and making it super tight, the bolt wouldn't strip out. It'd be the aluminum threads that strip out. Okay. So always pay attention to the materials that you're working with. Okay. Now, this next part is on extracting. And, you know, unless you're building custom parts, you might be not having to tap a lot of holes. But if you're working as a general mechanic, especially if you're working on older cars, you're likely to come off a broken nut or bolt. And so it's damaged, it's messed up, and you got to pull it out of there. We call that pulling that broken fastener out. We call that extracting. So let's see what we got here. First of all, we have an extractor set in the middle of a tap and die set. That's pretty common. The flutes on these guys are actually reverse thread, so that as I tighten these down, I actually turn them in a counterclockwise fashion, and they screw into that fastener. So here's a better job of that picture. So here's what happens. Let's say this is my material. Here's my bolt, and it broke off. The head of it broke off of there, so it's pretty flush with the material, right? What I first have to do is I got to center punch this thing, and I got to drill a pilot hole in the center of this thing. And it's tricky because I got to perfectly center that. So before we got to this point, we had to come down here and drill a hole perfectly in the center of that broken off bolt. Well, depending upon the grade of the bolt will depend on how strong of material that is, right? So it might not be too bad to drill into a grade 3, but if you're drilling into a grade 8, that's a pretty hard material. So that's going to be pretty hard on your drill bits. Don't be surprised if you need, you know, a fresh drill bit to get the job done, or if you're doing that work a lot, that you end up having to replace drill bits or at least have them resharpened. And you're going to have to really do a good job center punching this thing so you don't get your drill bit walking to the side and ruining your engine block or whatever that component is that we're trying to get that fastener out of there. So you first had to perfectly drill that hole in the center of that bolt. Then I can take my extractor and I can put him in my tap handle. And when I turn this guy counterclockwise, and if I hold this in my hands, if I turn it counterclockwise, you can see it actually goes down further and further into the work surface because the way these flutes are cut on the screw extractor, and it's tapered so it wedges in. And the idea is as you run this thing down in a counterclockwise motion. So I'll put that on here. This is run down in a counterclockwise motion. It actually helps pull the bolt up out of the component. Now, the nightmare scenario is if you get too overzealous with this, too greedy, and break off the screw extractor, and a lot of times we'll call them EZ outs. Well, if you break off the extractor or you break off the easy out, now you have this thing stuck in your engine or whatever the component is, and these are super hard metal. They're very hard, but that also makes them brittle. So you really have to be careful with them. Anyways, that's a pretty bad situation. And then you're trying to drill that thing out and it's going through drill bits. You're probably going to have to apply some heat. You're going to have to apply some penetrating oil. It gets to be a tough job. In some extreme cases, I actually have to heat this area up and get that thing almost cherry hot. And I'll have to put some beeswax on there and get the beeswax to wick down the threads to try to get that thing out of there. That's what we do in the machine shop when we have like exhaust studs and stuff broke off in our engine block. That's what you got to do. And it's tedious. It's time consuming. So that's just how it is. All right. So hopefully that made some sense. Now you can see that, hey, that was kind of a little presentation there, right? It wasn't like a zillion slides. What I want to do is go back to our course and show you what we have for you under modules. So I'll minimize some of this stuff. So here's our precision measurement. We did our fasteners. We'll expand our thread repair. It's the same basic stuff. There's the presentation, but there's a pretty good little video here. We'll give it a minute to load.
So here we have
that Mr. Gabe Clean Shoe put together for us using a tap and die set, using some screw extractors and stuff, so you can see how it's done. Okay, and he's even got like a nice snap-on kit, and you can see he's doing the activity there, just so you can see how it works in the whole process. He's got his GoPro helmet cam on there. So anyways, I know me talking about it isn't great, and even watching the video isn't fantastic, but at least by watching the video, you'll have a little bit more of an idea of how to do this particular job. It's super easy when it's on a piece of metal on your bench vise. Where's that bench vise there? There it is. That's as easy as it gets. Where it gets difficult is when you're doing this underneath the hood of your car or over your head or on your side, because you're trying to do it on a part on the car that you're trying not to have to take off the car. I will say that it's really hard to do that and to do a good quality job when you are underneath the car. And sometimes you just have to take the parts off of the car to get the job done correctly. Okay. So, this is a pretty easy one as far as an activity for this week. We have a little form that follows along with what Gabe is doing here. And I'll just click it here so I can get it to hopefully open up. It takes a minute. you know, and it will allow you to follow along. There's also a couple of handouts, which those will also take a while to get loaded. Here we go. I don't know why the quick view function of Canvas always takes so long. It's not loading a million pages, but anyways, if we're patient enough with it, and it could be my connection, but you will have a little worksheet there that you can fill out, just like we have each week, for you to do. Of course, there's a few quiz questions for you. So, anyways, that's what's new this week. I just can't stress enough that, you know, it seems kind of boring, but it is an important skill to have. So what I wanted to do now was just switch it over to the document camera to give you a little bit better view of what some of these things look like. So let me get that going here. New share. We're going to go to just our computer screen, which looks like a little bit of a mess. But with that, we will punch up our document camera. Awesome. Okay. So here's a better view of our Goodson drill bit and tap chart. And it's also a conversion chart, right? So, you know, if you want to know, like, what's 3/4 of an inch as far as a decimal? See if I can get that on the screen without a reflection. What's 3/4 of an inch without a decimal? Oh, that's, or in decimal, that's 750 thousandths. Well, look at that. It's just a smidge over 19 millimeters. So a lot of times I'll use a 19 millimeter socket, or if I can't find a 19, I'll use a 3/4 inch socket. So this is kind of nice because it gives you those conversions. Remember, our magic number is 25.4 as far as going from one size to the other. And again, it has a nice conversion here as far as metric to standard. If I go to the bottom of this form here, what you can see is like, okay, well, if I had a metric bolt that was, I don't know, let's say it was a an M8 by 125, okay? It tells me what drill to use, right? If I had an M6 by 10, I'm going to use a 5 millimeter. So it tells me what drill sizes to use so that I can drill a hole the right size to use the right tap and end up with the right threads. Here I have a tap handle. I also have a die stock or a die handle, and you can see that the dies go in there like so. Notice that they'll say, hey, start this side, and what you'll see is that it's tapered, so it's bigger here. So I'm going to put that in there just like so, and then I would loosen this. And then I could kind of tighten him up. I like these style of dies that are like the head of a fastener, right? That are 6-sided rather than the round ones, so you don't have all the pressure just on the little fastener on the side. Again, if I had a big tap like this one right here, notice how this thing is labeled. Let's zoom in on it. And I'll try to focus him. Okay, so this is a 18 millimeter by 1.5 millimeter thread pitch tap. Okay, so this is pretty big on the metric side. So that's metric. Let's look at this one. This one's standard. This is a 1/2 inch by 20. Okay. And look at this. It even says on it use drill 29/64. So it tells us what size drill bit to use. Okay. Here we have our extractor, and it's got printing on there that again tells us about the drill size. And again, when you're using drill bits, they have sizes on them as well. But because where we grab on our chuck, it becomes increasingly hard to read what's printed on here. So I can make out a 2, and maybe this can't be a number 2 drill bit. So what do I got here? Boy, I cannot read that at all. Okay. The other thing I want to point out to you is this drill bit has slipped in the chuck of the drill. I always want to tighten up that chuck of the drill like 3 different times, really get it in there. Because if it slips, it makes this little burr. And that little burr can make this drill bit not center correctly in the chuck. So what I will normally do is take a little file and get that little burr off of there. I picked this particular bit because it had the burr and it was extremely hard to read on here. So I would clean off that little burr, by the way, and watch out for that. And we're going to measure this thing. So our dial caliper, we'll zero him out. We'll put him on there. 219 thousandths. I'm going to tighten that up. Now, how did I get that? Well, I see 100, 200. So there's my 200. And it's just under 220, maybe 219 and a half. Okay. So with that, let's just figure out what size that would be. So if I got 219, what I can see here is 218.75. That's a 7/32 drill bit. Okay, so that makes sense. 7/32. So sometimes that's what you got to do, is you really got to measure stuff out. So, you know, nuts and bolts and wrench sizes and precision measurement, all these things go hand in hand. Okay, so they're super important to do together. And I'll tell you, like this, you know, you don't think, you probably wouldn't realize it, but this is an important tool to have in your toolbox, especially if you're going to do any type of fabrication. You can use the edge as a nice little straight edge here. I mean, it really is a handy little tool to have in your toolbox. All right, we're going to go ahead and exit out the document camera. And what we're going to do is we're going to get started on we're going to get jump started on some of the stuff that's due next week, or some of the topics, I should say, that are next week's topics. Because as we finish out our class, what we want to do is talk about electrical. We want to talk about a little bit of engine diagnosis, and we want to talk a little bit about scanners. So to do that, what I'm going to do is I'm going to open up this presentation we made that's about testing for spark and fuel and engine vacuum. And I want to use it to talk about, like, what does it take to make an engine run? So let me make sure I get the right screen share going here, and we'll just spend a few minutes talking about this. So spark, fuel, and vacuum testing, I should say, you know, basic diagnostics is really what this is. Okay, so we have here a car must have spark, fuel, compression, and all that in the proper order. And you know what I'm going to do here is I'm going to draw a clock with, I don't know, big hand, little hand. This is a pretty bad clock. All that has to happen at exactly the right time. time in the 4-stroke cycle, right? Intake, compression, power, exhaust. So I got to get my spark right at the top of the compression stroke, right? And if I don't do that, the engine's not going to run. A way I like to think about this, maybe a little bit more simply, is I like to say, hey, an engine needs 3 things to run. It needs heat, it needs fuel, and it needs air. Now, why heat, fuel, and air? Well, because it takes spark and the compression of our engine to give us the heat that we need. Fuel, well, that's going to come from our fuel delivery system. And the air, hopefully that's going through our air filter. But I've had cases where, rats a car had been sitting in somebody's driveway. Rats built a nest in the air box and the engine couldn't get any air. I've also had cases where a car wouldn't start because the exhaust system was so restricted, we couldn't get air into the motor because we couldn't move air out of the motor. Okay, so sometimes air becomes a factor for you. All right, well, heat, fuel, and air. So a couple things you don't want to forget is don't forget to check the battery, okay? Our battery needs to be able to supply us with electrical pressure or voltage. And that battery should be fully charged up at 12.6 volts before we go to crank over our car, all right? I have here that computer-controlled vehicles may not operate properly below 10 volts, and I would say that's the case. In fact, a lot of cars, they get below 10.5 volts, and they might get upset, and they might not start. So that's my normal threshold is 10.5 volts while cranking. Know the cranking battery volts before diagnosis is performed. So I would look at what's my battery's voltage while I'm cranking over the car. We call this an available voltage test, and I really like it to be above 10.5 volts. I've had a few students with me this semester in our multimeter class. We talked about that at length. In fact, I had the students do that test, and then I did a video of it as well, that available voltage test while cranking. So anyways, we will talk more about that part next week. But so at this point, let's just assume that, our engine cranks over and the car doesn't start, okay? Well, I would ask myself, hey, does the car have spark? Okay, so we can crank the engine and check for that spark. And how do we do that? Well, we put on a little one of these spark intensity testers. So you disconnect the spark plug wire, you put one of these little guys on here, this part clips to the engine block, and as you crank over the car, you might need an assistant or somebody to help you, but you should see a pretty bright blue spark jumping across the inside of this thing as you crank it over, okay? So bright blue, especially sometimes if you're outside in sunlight, it's hard to see. So you might have to like put, some towels over you, put a canopy over it, or be doing it inside, because sometimes it's hard to see this bright blue. I know we say bright blue, it's hard to see sometimes outdoors, okay? So figure out a way to dim the lights, and you should see a nice bright blue spark there. If you don't see that, then we've done what I call established a condition. My condition is that I don't have spark, and that's what's keeping the engine from starting, right? And I kind of have a direction to follow, okay? Now, I do need to back up a step, though, and that is, I said right here, crank the engine, right? Crank the engine. Well, what we're assuming here is that the engine cranks. So I'm going to use my text tool here, and I'm going to just put no starts. there's different kinds of no starts. There's no click. There's a no click, no cranks, no start. There is where it goes click, but it doesn't crank over. And then there's no. And then there's ones that don't crank at all, right? And these are three totally different scenarios, guys. So let's say we have a no start. If we have a no click, no crank scenario, well, that's a different deal, right? That could be different things. If I have a click, no crank, that's another deal. And then I have no cranking at all, which you know, essentially is like no click, no crank. But what about if I have cranks over well, cranks over well, but the engine doesn't start? Well, that's kind of what this scenario is for. So if I have a car that you turn the key and it goes, right? It's cranking over. And so that tells me that, hey, the battery's got voltage, the starter motor's working, the engine's not mechanically seized, it's not mechanically frozen up, but it's not starting. Well, now I'm thinking, okay, maybe I got a spark issue, maybe I have a fuel issue, I could have a timing issue, right? But if it's any of these over here, I'm thinking that maybe I have a battery that's failed, or I have a starter that's failed, a starter solenoid, possibly an ignition switch. So I'm going to do a big line right here in the middle of the screen, and these two things are separate. They're separate deals, okay? Over here, it's more electrical only, and on this side, it could be mechanical, it could be a bad fuel pump. So when we're testing for spark, well, we're testing for spark because the engine's cranking over and it's not firing up, okay? So I'd be using a spark tester if I had an engine that cranked, but it won't fire up. If I had where I turn the key and it was a no click, no crank, like I turn the key, it's nothing, my tech tip for you guys is turn your headlights on. If you turn your headlights on and you turn the key and the headlights dim, well, that's likely a dead or failing battery that can't supply the power needed. But if the headlights stay bright as I turn the key and it doesn't crank over or anything, well, that's probably a bad connection or maybe a bad starter motor, high resistance starter motor in the car, okay? So one of my tips is if the car doesn't crank over, turn the headlights on and see what the headlights are doing as you go to crank it over. It's almost kind of like a informal voltmeter that you have on there, okay? That'll give you a direction. If it does crank over, and it cranks over, and I always listen to how it sounds, okay? I want a nice, even cranking rhythm. I don't want it to go da-da-da-da-da-da-da-da-da-da, like up and down, like I have some cylinders with compression, and I have some cylinders without compression. I want it to have a nice, smooth, even cranking rhythm. And if it has that, and it doesn't start, one of the first things I would do next then would be to check for spark with the spark tester, just like this, okay? Now, let's say I do that and I have some spark here, okay? I go, okay, well, I have spark. The next thing I'm gonna say is, do I have fuel? And I'll tell you what, it's happened on more than one occasion where I go, hey, I wonder if I got a fuel issue. And I go, well, the gas gauge does say the car's empty. I wonder if this person just ran the car out of gas. And I've had that happen at least a dozen times over the year where they just ran the car out of gas. And all kinds of different cars too. Like when cars like the Toyota Prius was new, right? It's a hybrid electric vehicle. I had a couple customers that they just ran their Prius out of gas, and they said, "Oh, well, I thought, you know, when it ran out of gas, the electric stuff kicked in, and that's how it worked." And it's like, no, it still needs gas in order to run. So, anyways, so if I have spark, the next thing I'm looking for is fuel. That's the next spot that I typically try to go to next. Okay. I got all kinds of things of, you know, things to check if you don't have spark. Leak ignition coil, low voltage to the coil, defective pickup, defective module. We'll get more into that stuff in the future. Let's talk about this one, right? Check the fuel tank. Does the gauge work? Put some gas in it, right? Just like I was talking about. You can test for fuel pressure, but now I'm going to go off the script. And what I'm going to do here is go back to the internet, and I think this will be a pretty good thing to wrap up on for us tonight. And that is a can of starting fluid. Well, you know, one easy way to see if fuel is your issue is to give it some fuel. Get a bottle of starting fluid and squirt it down the intake and see if it runs for a few seconds off starting fluid. Another thing, if you don't have starting fluid handy, you could use some carb cleaner as starting fluid. And guess what? That works pretty good as well. Okay. But what does not work very good is like WD-40 or brake cleaner is kind of hit or miss. And you might think, well, why is that, right? Because they're all flammable. WD-40 is flammable. A lot of you guys did your MSDS sheet on WD-40. It's flammable, but it's not flammable enough a lot of times to fire up quickly and run on your engine. So starting fluid would be ideal. Carb cleaner can work in a pinch. And what you would do is you would remove your air filter, maybe go back behind your mass airflow sensor. So you might take this whole boot off of the engine. So I could take this boot off of here, spray some directly into the motor, slide the boot back on real quick, and crank it over and see if it fires up. If it fires up and runs for a split second off of the fuel that I put in my motor, I know I have a fuel issue. Okay. In fact, a lot of times I'll do this before I mess around with the spark tool. And you go, well, why would you do that? You know, it was the first thing you talked about in your presentation. Well, it's that not, you know, it's a presentation that we all kind of shared on. So I didn't come up with the beginning. But I always do whatever's easiest. So let's say I have this nice Camaro engine here and I'm working on it and it's a no start, but it cranks over well. Man, those spark plugs look like they're pretty buried to get to, right? So I'm not going to mess with that. I'm going to, you know, get my flathead screwdriver, disconnect that clamp, pull this boot back, spray some starting fluid in there, slide that thing back on and see if it starts up. Okay. It'll only fire and run for a few seconds. But if it does fire and run for a few seconds, you know what I've established? Hey, guess what? I got spark because when I gave it fuel, made the engine run. So I have spark, I have good compression. My problem is fuel. Okay. My problem is fuel. So maybe there's no fuel in the tank, right? maybe maybe my electric fuel pump failed on me. Okay. Um, so at that point, once I have established that the engine will run if I give it fuel, now I'm going to hook up a fuel pressure gauge like one of these right here and see if I have fuel pressure there. Okay. I'll also listen back by the gas tank. I might even sometimes take the gas cap off so that I can listen to the tank a little bit better to see if I hear the electric fuel pump running. Okay. So again, if you have a no start, you want to ask yourself, well, does it crank or is it a no crank situation, right? If it does not crank, I'm thinking maybe I got like a battery issue or a starter motor issue, or maybe even an ignition switch issue, right? But if it cranks over, well, then it's probably spark or fuel, something like that. It could be compression, but it's likely not a battery type issue. And I say this all the time because I'll be at, it doesn't matter what auto parts store. I'll be at O'Reilly's. I'll be at AutoZone, and people are there. They're getting in the zone, and I'll see some poor sucker, and he's in the parking lot. His car doesn't start up, right? And he's out there. He's cranking it, and he goes in and says, "Oh man, what do I need?" And they're like, "I don't know. Well, let's sell you a battery." Well, it's like, hey, if the car is cranking over that fast, probably doesn't need a battery. Okay. You're probably just dropping $130 or $150 or more for no reason. It's probably something else. And that's why, there's a lot of value in what we do, which is a proper diagnosis. So you're not replacing parts that you don't need to change. Okay. So again, if you have a car that's a no start, but it cranks over, that's probably a spark issue or a fuel pump issue, something like that. Now, if it does not crank, then I'm looking at battery and starter, that type of stuff. So what I like to do on diagnosis is as quickly as possible, try to establish a condition, right? Is it a lack of spark? Is it a lack of fuel? Is it a lack of voltage from the battery? And then once I establish that condition, that gives me a direction to go with my diagnosis. Okay. So that's a little intro into the diagnosis stuff that we're talking about in class, just to give you guys some basics. Of course, remember this week, our big thing was thread repair, which kind of followed up on our nuts and bolts fastener segment, which also followed up on the precision measurement. Next week, we'll get more into electrical and then work that back into the no start diagnostics that we were talking about tonight. And we'll end up finishing our semester talking about scan tools and these cheap little ELM interfaces that you can buy for right around $20 and do quite a bit of diagnosis with. In fact, this is what we're using now for our AT 188 classes. And we're getting into some pretty good diagnostic and case studies in that. So it's pretty interesting stuff. So I hope you got something out of that tonight. And remember, our tech tips are, if you're doing thread repair and stuff, right? Always lubricate your drill bits. I always put a little bit of oil on the tip of the drill bit there. Lubricate your taps and dies when you use those as well. It's good to have a dial caliper. This is a good stocking stuffer for the automotive person in your life. Very handy tool to have. And then when we worked into diagnostics and no starts, a can of carburetor cleaner or starting fluid could go a long ways. That by itself is a diagnostic tool, right? So multiple tech tips for you guys tonight. I always like to give you guys lots of those. You guys are doing, as a class overall, you guys are doing absolutely fantastic on your assignments. It's really come together. Lot of A's, a lot of B's in class, and it's really nice to see. So with that, that's all the stuff I had. I'm going to go ahead and stop the recording.